Hi everyone, my name is Chujin Song. Today I'm going to carry out an experiment of use acidified potassium dichromate 6 to distinguish propana and propanon. Before that, I would like to conduct an analysis of Hirarc. So basically, these are the form of the Hirarc. Potassium dichromate 6 is an odorless, highly water soluble, and a bright red-orange crystalline solid. So, as a hexavalent forming compound, potassium dichromate 6 is carcinogenic and highly toxic. It's also very corrosive, and skin or eye contact can cause severe irritations and burning sensations, and even leads to blindness. It's also affecting the reproductive organs and human unborn children. Hirarc process requires 3 steps. The first step is hazard identification. We need to classify the work activity and identify hazards include self-hazard, safety hazard, and environmental hazard. In this instance, health and safety hazard are mostly identified. The first step of work activity is a small amount of acidified potassium dichromate 6 solution is added into test tube A and B. This reaction can cause severe skin burn and eye damage and may cause respiratory irritations and cancer. This is because the chemical is toxic, corrosive, and carcinogen. Next, a few drops of propana and propanon are added into test tube A and B respectively, and both mixture will stir with glass rod. Due to acidified potassium dichromate 6 is a strong oxidizer, it contact with organic material like propana and propanon may cause fire and fatal if inhaled. After that, both mixture are warmed gently in water bath for a couple of minutes. The color change was observed. In the durations of warming, heat may build pressures, spreading fire, and increase risk of burns and injury, which can cause severe burns to every area of contact. Lastly, the solutions are neutralized with sodium hydrogen carbonate and disposed in an appropriate waste container. If you do not handle it well, it can cause environmental pollutions and skin irritations on area contact. The next step is risk analysis. Risk analysis can be done by qualitative, quantitative, and semi-quantitative analysis. In this experiment, qualitative method is used by using the formula of likelihood times severity equals to relative risk. So as you guys can see, the L means likelihood, while S is severity, and RR is relative risk. So as you all can see, the first step, the relative risk is 12, second step is 6, third step is 9, well, fourth step is 12, and the last step is 2. So the yellow colors means medium risk, while green color is low risk. Therefore, the most important existing control measure is use proper personal protective equipment. For example, cover shoes, lab coat, safety goggles, and proper gear. The third step is risk control to ensure the safety of students, lab assistants, and demonstrators. They need to enforce personal protective equipment (PPE) at work, use fume hood to carry out the experiments, and work in insulated and air-conditioned places, and lastly, safe laboratory practice. If the spillage of acidified potassium dichromate 6 is happened, take the following steps. Firstly, eliminate all ignition sources. Next, moisten spill material first, or use a HEPA filter vacuums for clean up and place into sealed container for disposal. Lastly, ventilate and wash area after clean up is complete, but take note that do not wash into silver. That's all from me. Thank you.